Okay, in this video I'm going to present a simplified way to read IR spec. As we see here, we have an example of an IR spec, and so I'm going to just quickly go through the major peaks and what functional groups they represent. Let's go down right here. I've set up this little table here with the corresponding wave numbers on the bottom row here to this graph. Okay, so if you ever are looking for, well, if you see an alcohol on the IR spec, it will actually show up centered right around the 3300, and it will be a very broad, it'll look something like this, just a big broad would be an alcohol. Now if you have a mean, and the mean stretch, this bond here, it actually will have a couple little peaks off of it. So let's say, for example, we had a mean with a couple hydrogens on it. It would actually come up. It's a little bit broad as well, and then it would have like a couple peaks, something like that on it. If it only had one hydrogen, many times it would only have one peak, and so on. Okay, if you have an amide, which looks like this, the amide stretch right here, it will appear on the 3300 as well. And if you have the terminal alkyne proton, this stretch will appear here as well. And I will talk in a second about how you can tell these two apart. Okay, let's move over to the 3000, and let me actually, this won't quite be to scale anymore, but I need the room, so I'm just going to slide it over. Okay. Okay. So around 3000 here, on the left side of it, you'll have the sp2 CH stretch. Okay, so that's let me draw it totally on the left side. sp2, of course, meaning sp2 hybridization. So this stretch right here off of this sp2 hybridized carbon would be an sp2 CH stretch. That will show up to the left of 3000. sp3 CH stretch is just to the right. So sp3 would be, of course, this stretch right here. You also, at 3000, you have your acid stretch. Carboxylic acid will show up around here, and also will many times be kind of a broad appearance. Okay, let's go over to the 2200. Here you have your nitrile group, carbon triple bonded to a nitrogen, as well as on the left side. On the right side, see your carbon triple bonded together, your alkyne. Okay, and many times this can be a very weak signal, meaning that it doesn't, it's not very tall. Okay, let's move on to 1700. Here you find your carbonyl stretch, and this is very intense. I actually am writing these. As I write these, I'm writing them on purpose where I am, and that's because for a carbonyl, for example, is very intense, which is actually in this one we have here. So you can see it's really intense, and so I place it further down to show that it's intense. Okay, so I'll be right around 1700. And let's go to 1600. Just to the left is where you will find your alkenes, and the more intense is usually your nitrogen double bound to the carbon. Okay, usually right on 1600 or pretty close to right on it, you will find your peak for an aromatic ring. Okay, now at 1100 there's a special case for carbon-oxygen stretch, and this is useful for identifying esters. So if you have something like this, right, it's hard to really know when you have an ester, but this, if it's there, it doesn't mean that you have one, but the absence of it shows that you don't have one. Okay, so if you're thinking maybe an ester and this is not there, it is not an ester. Okay, now you may have been wondering, how do you differentiate between, for example, the amide here and the terminal alkyne proton? Well, let me show you this. If you have this stretch here, then you know it's going to show up in conjunction with the carboxylic, or with the carboxyl group, right? So look for these two together. In the same token, if you have an alkene, then you also know there will be a peak for the sp2 hybridized proton. Okay, if you have a carboxylic acid, same thing. You will also have the carbonyl. Okay, and one more thing that I forgot to draw in earlier, but I will now, is the aldehyde, which looks like this. Will many times make a little shoulder. Like you'll usually have the sp3ch almost as always on all organic compounds, and if you have an aldehyde, you'll have sort of an extra little shoulder, like a little shoulder peak on it, something like that. And if you have this little extra peak, it'll also show in conjunction to your carboxyl group. So these appear together, and actually on the ester as well. An ester will always appear with the carboxyl group. Okay. So this actually I just have memorized. So if you memorize this, you can actually interpret. I mean, I would probably go deeper into it, but this is a really good place to start, and you'll be able to identify many of the major peaks that you will see. For example, this is a ketone, so we have the carbonyl peak here at about 1700, and we should have the sp3ch stretch right at about to the right of 3000, which we do there. So, okay. Thanks for watching.